Wireless sensor networks are currently in use for several applications, including environmental monitoring and intelligent transportation systems. However, there is some disadvantage for traditional digital sensors that are incapable to meet this demand because of their high power consumption, high complexity, and the use of non-biodegradable materials. Our purpose for this design is to develop low-power, low-cost sensing devices. Then we can manufacture them using biodegradable materials. Compared to the traditional digital sensors, we use a single field effect transistor to encode the value instead of using the analog to digital converter. The same goal can be achieved with lower power consumption and lower complexity, which is the technique of analog joint source channel coding.
Analog joint source channel coding, in general, is utilizing a low complexity technique which is used to reduce the power consumption and cost. First of all, we would like to introduce the transmitter antenna part about how it can collect and quantize data in the wireless sensor network. The principle is to compress two signals such as temperature and humidity into one control distortion. In this case, a singular MOSFET is used to convert two groups of data to a single group. Through this technique, we are able to achieve a few tens of microwatts power consumption for the encoding circuit. With such a low power consumption, the analog sensors that comprise the lowest tier of the wireless sensor network only sense and transmit, but do not perform any processing like traditional digital sensing modes. Due to this, analog is much cheaper than digital, and it's a better choice for people to widely select. Here is the pre-circuit built by Group 64, which does the proper quantization of gate to source voltage. We select 1 to 5 voltage as our input with 0.5 quantization level.
In order to test the functionality of the system, we simulate 3 different scenarios for signal transmission. The first one is the scenarios of countryside, which have less obstacles and less reflectors. The second one is simulating the scenario in the city, which have more obstacles and interference. At last, we simulate the signal transmission in a moving transmitter or receiver, which include the Doppler effect.